Hi guys, welcome back. This is the continuation of the previous videos, part 1 and part 2. If you did not watch it yet, please do watch it. Now let us continue with the 4 more questions. Let us observe the 34th question. Find the solution of the given pair of linear equations by graphical method. 2x plus y is equal to 8, x plus y is equal to 5. In this question they have given us two equations. We have to solve this and find the value of x and y and solve it using graphical method. First let us try to solve these equations. They have given us two pair of equations, 2x plus y is equal to 8, and one more equation is x plus y is equal to 5. Let us draw a box. This is x and this is y. Now let us consider the first equation. 2x plus y is equal to 8. Now when x is equal to 0, the value of y becomes 2 into 0, 0, y is equal to 8. So x is 0, y is 8. Now x is equal to 1. When x is 1, 2 into 1 plus y is equal to 8 minus 2, y is equal to 6. So when x is equal to 1, y is 6. Now let us focus on next one. Now when x is equal to 2, 2 into 2, 4, y is equal to 8 minus 4 is equal to 4, y is 4. Now last value, when x is equal to 3, 2 into 3, 6, y is equal to 8 minus 6, y is equal to 2. Now let us look into one more equation. X plus y is equal to 5. We draw the same box here. X and y. X is 0, 1, 2 and 3. When x is 0, y becomes directly 5. When x is equal to 1, y is equal to 5 minus 1, y is equal to 4. When x is equal to 2, y is equal to 5 minus 2, that is 3. When x is equal to 3, y is equal to 5 minus 3, y is equal to 2. Done. Now we have got all the values for corresponding values of x. Now the job left for us to do is a graphical solution. Let us see how to solve this graphical solution. Consider this as a graph. This is the origin, 0, 1, 2. This is the positive x-axis and this is the negative x-axis. Positive y-axis and negative y-axis. Just you have to compare the values of x and y, and just you have to point the points and then you have to draw a graph. Now x is 0, y is 8. Your 0, you have to observe 0 in x-axis, draw 8, 0, 8, so on you have to draw. You will get a straight line like this, and for x plus y is equal to 5, when you draw this you will get a curved line like this. The point joining which both the curves, you have to consider what is the x and y point in that. That itself is the solution. When you draw this properly, you will get x is equal to 3 and y is equal to 2. Both the curves intersect at this point. This is the solution of this pair of linear equation. Finally you have to write x is equal to 3, y is equal to 2. Don't forget to write the scale on the top right corner of the graph. You have to write scale x-axis 1 centimeter is equal to 1 unit. Y axis 1 centimeter is equal to 1 unit. Don't forget to write this. Let us now solve the next question, 35th. There are two questions, part A and part B. Let us focus on part A. In an arithmetic progression, the sum of first n terms is 210 and the sum of first n minus 1 terms is 171. If the first term of the arithmetic progression is 3, then find the arithmetic progression and find its 20th term. Let us first observe what is given in the question. The sum of first n terms is given, that is 210. We'll write that. Sn is equal to 210. And the sum of first n minus 1 term is 171. We'll write that. Yes, n minus 1 is equal to 171. First term is given. We have to find the arithmetic progression and 20th term. First term A is equal to 3. We have to find the arithmetic progression and 20th term. We know the formula for n terms of arithmetic progression, that is Sn is equal to n by 2 into a plus an, that is first term plus arithmetic progression up to n terms, is equal to, they are given the value of Sn, that is 210, is equal to n by 2, first term they are given 3, substitute that, and the job left here to find an. Let us look what is an. An is nothing but Sn minus Sn minus 1. An is equal to sum up to n terms, that is 210, minus sum up to the terms of n minus 1, 171. An is equal to 39. Let us substitute the value of n here, 39. We will get the equation and we have to solve for the value of n. N is equal to 10. We got the value of n equal to 10. Now we have to obtain what is the value of d, that is the common difference. We know the formula for an, for arithmetic progression, nth term of an arithmetic progression. An is nothing but nth term of an arithmetic progression, that is a plus n minus 1 into d. We know the value of n, that is 39, that is equal to, we know the value of a, 3, plus n is 10, we already obtained that here, substitute that 10 minus 1 into d. By solving these values, you will get d is equal to 4. Now they are asked us to solve for what is the arithmetic progression and the 20th term. Arithmetic progression is given by a1, a2, a3. A is the first value, that is 3, they are already given 3. A2 is a, how to find the value of n, a plus n minus 1 into d. Here they are given 2. 2 is 3 plus 2 minus 1 into common difference is 4. This is 4 plus 3, that is 7. So on, find the value of a3. a3 is equal to 3 plus 3 minus 1 into 4. That is, what was the 8, 9, 10, 11. So the arithmetic progression stands like this, 3, 7, 11. Then you need not of solving everything, just to put 3 dots, that is more than enough. Now let us find the 20th term, what they asked, one more in the question. A20 is equal to a plus n minus 1 into d. We know the value of a, 3, n is 20, minus 1 into common difference is 4. That stands the value for a20, that is 79. That itself is the answer. Now let us move into the 35th question, part B. The sum of interior angles of a polygon of n size is n minus 2 into 180. If the interior angles of a pentagon are in arithmetic progression and its least angle is 72 degree, then find the interior angles of the pentagon. We know pentagon has 5 sides. They are given the sum of that n sides, sum Sn. They are given the value of Sn, that is Sn is equal to n minus 2 into 180. This they are given in the question. Interior angles of a pentagon are in, and they are told that interior angles of a pentagon are in arithmetic progression, that is having a common difference, and the first least angle they are given, that is 70 degree. So we know the value of n is 5 because pentagon has 5 sides. We know we will calculate S5. S5 is equal to 5 minus 2 into 180. We got the value of S5, that is 54 degree. We know now the value of S5 is 54. Now let us consider, let A1, A2, A3, A4 and A5 be the interior angles of the pentagon. Now by what we have considered, A1 the value they are already provided that in the question, that is the first term. We know the value of A1, that is 72 degree, and Sn, that is 54 degree. 540 Sn is 540. 3 into 180. We know the value of Sn is equal to 540. Now let us apply the formula. Sn is equal to n by 2 into 2a plus n minus 1 into d. We know the value of Sn, that is 540. Pentagon has 5 sides, 5 by 2. First value they are given 72 degree, plus number of sides is 5 minus 1 into d. By calculating this, we will get the value of d, that is 18. Now A2 is a plus n is 2, 2 minus 1 into d, a plus d, that is 18 plus a is 72, 72 plus 18, that is 90 degree. A3 is a plus 2d, that is 72 plus 36, that is 108 degree. A4 is a plus 3d, that is 72 plus 54, that is 126 degree. A5 is a plus 4d, that is 72 plus 72 plus 72, that is 144 degree. Now we got all the values for A1, A2, A3, A4 and A5. That itself is the solution. Now let us focus on the next question. This is a long question. We'll first understand what is there. In the figure, the poles AB and CD of different heights are standing vertically on a level ground. From a point P on the line joining the foots of the pole on the level ground, the angles of elevation to the tops of the poles are found to be complementary. The height of CD and the distance PD are 20 root 3 and 20 meter respectively. If BP is 10 meter, find the length of the pole AB and the distance AC between the top of the poles. They are given as the diagram. To solve this, we have to use one construction. We have to join this line, that is, we'll consider this point as E. We'll consider this angle as theta 1 and this angle as theta 2. Now Let us observe what is there in the question. They are given poles AB and CD of different heights. These are the two poles AB and CD. These are of different heights, are standing vertically from the level ground. From a point P on the line joining the foots of the poles on the level ground. These two lines are joined by a point P. And the angles of elevation of the tops of the poles, angles of elevation to the tops of the poles are found to be complementary. What is complementary is, it is 90 degree. This angle, what we have considered theta 1 and theta 2, this angle, when we add this gives us 90 degree, that they have mentioned. Now the height of CD and the distance PD are 20 root 3 and 20 meter respectively. They are given us the height of CD, that is 20 root 3, and the distance PD, P to D, that is 20 meter. And they have given that BP is 10 meter. We have to find the length of the pole AB and the distance AC, this between the top of the poles. Now we know theta 1 plus theta 2 is equal to 90 degree based on what they are given in the question. We'll first write that theta 1 plus theta 2 is 90 degree. Now let us consider tan theta 1. What is tan theta? Opposite by adjacent. This is theta 1. Opposite is 20 root 3. Adjacent is 20. 20 root 3 by 20. We'll get the value of tan theta 1 is equal to root 3. Theta 1 angle is 60 degree. So on we'll solve for tan theta 2. Opposite is not given, that is AB. Adjacent is, we know, that is BP, that is 10 meter. We'll get the value which is stands on equation of AB, that is AB is equal to 10 root 3 by 3 meter. The value of tan theta 2 we can obtain by adding, we know the value of theta 1 plus theta 2 is equal to 90 degree. Substitute that, we'll get the value of theta 2 30 degree. Tan 30 is equal to 1 by root 3. So we'll get 1 by root 3 is equal to AB by 10. AB is equal to 10 by root 3. Now multiply both the numerator and denominator by root 3. This becomes 10 root 3, and root 3 into root 3 becomes root 3 whole square, become root 3. That itself is AB, 10 root 3 by 3. Now let us focus on next steps. One more we know, what is C plus ED is equal to 20 root 3. This is the construction drawn, this is the midpoint. We have considered that it as A. Now we know C plus ED is equal to 20 root 3. We know the value of ED. C plus 10 root 3 by 3. That is equal to 20 root 3. Because ED is equal to AB. Because those are the breadth of the rectangle. When we draw line segment here, this becomes breadth of the rectangle and this becomes the length of the rectangle. So both the breadths of the rectangle are equal. Now we will find the value of C. C is equal to 50 root 3 by 3 meter. Now let us apply Pythagoras theorem to triangle CA. We will apply the Pythagoras theorem here. We know the value of C, that is 50 root 3 by 3 meter. We know the value of AE. When we add BP and PD, that is 30. We know the value of AE. This is 30. Now we have to find the value of AC by applying Pythagoras theorem. Let us apply Pythagoras theorem. AC square is equal to 50 root 3 by 3 whole square plus 30 square. Hypotenuse square is equal to adjacent square plus and altitude square. Now let us find the value of AC. AC is equal to square root of 5200 divided by root 3. Now if we will get the answer, that is 20 root 13 by root 3. We have to remove the multiples of squares which are there in 5200. We have to multiply, go on multiplying like 2 into 2 into 2. From how many it will stop, then remove that outside the root. Remaining is 13, which we can't multiply with the square numbers. Then multiply both the numerator and denominator by root 3. That becomes 20 root 39 by 3. That is the answer of this question. Now let us focus on the next question, 37th question. Prove the basic proportionality theorem or Thales theorem. This is the proof. To prove this kind of question, first you have to write the theorems. For some questions they will give the theorems, just we need to write the proof. For some questions they will just ask the question, you have to write the proof along with what is given, any construction you have done, everything you have to mention in detail. First we will write Thales theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. I'll explain what is this. Thales theorem states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Now if we consider a triangle and if a line is drawn to parallel to one side of a triangle, so consider we have drawn a line parallel to one side of a triangle, the other two sides are divided in distinct ratio. If we draw a line parallel to one side of a triangle, the upper side is equal to the lower side, whatever the point where the line cuts the other side of a triangle. Now let us prove the theorem. Let us consider a triangle here, ABC, and we'll think a line is drawn parallel to one side of a triangle, that is the line which is drawn parallel is DE. Now we require some construction to prove the theorem. We will consider this as N. We will join B and E. We will join D and C. We know the area of a triangle formula, that is half into base into height. This you can use only when one angle is 90 degree. When all the angles are other than 90 degree, you can't use this formula. So we have to look into other formulas. When the angles are all different other than 90 degrees. Now we will first write the given. What is given? ABC is triangle and we have drawn DE, a line that is parallel to BC. This is the line drawn parallel to BC. Now what we have to prove is, when this line cuts the triangle DE, AP by DB, AD by DB is equal to AE by AC. These sides are divided proportionally, that is equally. When this line cuts the side of a triangle, these two sides are divided at equal ratios. To prove AD by DB is equal to AE by EC. Now we'll write what we have done the construction for solving this theorem. You have drawn DM, that is perpendicular to AE, and EN perpendicular to AD. We'll write that DM perpendicular to AC and EN perpendicular to AB. Then more, we have joined B and D, join D and C. We have write that join B and E, joined C and D. Now first we'll calculate the area of triangle AD. Area of triangle is half into base is this D. We'll consider this half. This is the triangle AD, base into side. Height, we'll consider the height as EN. Now area of triangle ADE, half into base is AD, height is EN. ADE triangle, base is AD, height is EN. Now next we'll focus on area of triangle DEB. DEB, this triangle, base is DB and height is EN. This is the height. Half into DB into EN. You consider this as the first equation and this as the second equation. Here both the heights of triangle ADE and DEB are equal because the line is cutting at the middle of this point, so this both angles becomes 90 degree. So height of the triangle ADE is equal to height of the triangle DEB. Now let us consider the next area. Area of triangle ADE, that is half into AE into DM. These both angles are equal, the heights are equal. Just we replace the base of the triangle, that is AD by AE. AD is equal to AE, and the heights, instead of EN, this time we have taken it as DM. Now let us consider the area of triangle DEC, that is half into base is EC, DEC, and height is DM. This triangle height and this triangle height both are equal because this is complementary. When it is 90 degree, both the heights will be equal. Let us consider this as the fourth equation. Now we will do equation 1 divided by equation 2. We will get area of triangle ADE by area of triangle DEB is equal to half into AD into EN divided by half into DB into EN. When we solve this, we will get AD by DB. We will consider this as the fifth equation. Now let us divide equation 3 divided by equation 4. We will get area of triangle ADE divided by area of triangle DEC is equal to half into AE into DM divided by half into EC into DM, that is equal to AE by EC. We will consider this as sixth equation. Now we want, by looking into this diagram, we can say area of triangle EBC, that is this triangle EBC, and area of triangle DEC. These triangles are equal because two triangles lying on the same base. These both the triangles, when you consider this triangle and this triangle, these are lying on the same base DE, so both the triangles are equal, have equal area. So area of triangle EBC is equal to area of triangle DEC. We will consider this as seventh equation because the reason is two triangles lying on same base and between same parallels have equal area. Now we will find area of triangle ADE by area of triangle DEB. That is, area of triangle AD by triangle DEB is AD by DB, that is equal to area of triangle ADE by area of triangle DEC. Now AD by DB is equal to AE by EC from equation 5 and 6. This is obtained from 7th equation, that is area of triangle EBC is equal to area of triangle DEC. Now AD by DEB, we have just divided the sides. AD by DB is equal to AE by EC, that is from 5th and 6th equation. This is area of triangle DEB is equal to area of triangle DEC. These are the two triangles lying on the same base DE. So area of triangle DEB is equal to area of triangle DEC. Now area of triangle ADE by area of triangle DEB is equal to area of triangle AD by area of triangle DEC. So we can write from this AD by DB is equal to AE by EC, that is from 5th and 6th equation. Now let us focus on the 5 mark question. An insect control device made of a cylinder, a frustum of a cone and a hemisphere attached to each other is as shown in the figure. Sticky liquid is completely filled in the hemispherical part. If the radii of hemisphere and cylinder are 21 cm and 14 cm respectively, and total height of the device is 60 cm and height of the cylinder is 15 cm, calculate the curved surface area of the device and also find the quantity of the sticky liquid in the hemisphere. They are given as a diagram. You have to find the curved surface area of this whole device and calculate what is the quantity of the sticky liquid that is there in the hemisphere. We'll see how to solve this. First we'll find the radius of the hemisphere. That is equal to R to H, that is 21 cm. They are given the radius of the hemisphere, that is 21 cm. Now you will find the radius of the cylinder, that is R2C, that is equal to 14 centimeter. Radius of the cylinder they are given, that is 14 centimeter. We know the height of the cylinder 15 centimeter. We'll write that. R2C, that is 15 centimeter. This is radius of the cylinder and this is radius of hemisphere. Now you know the total height of the device, that is h is equal to 60 centimeter. They are given in the question. The total height of the device is 60 centimeter. Now height of the frustum is the total height of the device and height of the cylinder minus radius of the hemisphere. Total height of the device is known, that is 60 centimeter. Now we'll find the height of the frustum. That is HF. That is equal to total height minus height of the cylinder minus radius of the hemisphere. 60 minus 15 minus 21. 15 is the height of the cylinder, 21 is the radius of the hemisphere. That gives us height of the frustum is 24 centimeter. Now we have got the height of the frustum. We will now calculate the curved surface area. Curved surface area of cylinder is 2 pi RC, that is the radius of the cylinder, into height of the cylinder. 2 pi into 14 into 15. We will calculate the curved surface area of hemisphere. Formula is 2 pi radius of the cylinder to the power 2, that is 2 pi into 21. Radius of the cylinder is 21, radius of the hemisphere is 21 to the power 2. Curved surface area of the frustum, that is pi into R1 plus R2 into height of the frustum. R1 is nothing but radius of the cylinder and R2 is radius of the hemisphere. We know R2 is equal to 21 centimeter, and by that HF we know, that is 24 centimeter. Height of the frustum, that is 24 centimeter. You have found out now height of the frustum. Now we will find the CSA of the frustum, that is pi into 14 plus 21 into 24. 14 is the radius of the cylinder and 21 is the radius of the hemisphere. Now that we will find the total curved surface area. Is the curved surface area of the cylinder plus curved surface area of the hemisphere plus the curved surface area of the frustum. Volume of the sticky liquid what is present in the hemisphere, that is 2 by 3 into pi radius of the hemisphere to the power of 3, that is 2 by 3 into pi into 21 to the power of 3. Radius of the hemisphere is 21. Substitute pi as 3.14 or 22 by 7. We'll get this volume of the sticky liquid is 3087.33. We have left this incomplete to find the CSA of a cylinder, CSA of hemisphere and CSA of frustum and the total CSA. We'll substitute the value of 3.14. That gives us the answer. CSA of cylinder is 1320 centimeter square. CSA of this is the cylinder. CSA of the hemisphere is equal to 2772 centimeter square, and CSA of a frustum is equal to 1092 centimeter square. Now we will calculate the total curved surface area. That is the CSA of a cylinder plus CSA of the hemisphere plus CSA of the frustum. We know the value of CSA of cylinder is 1320 and the CSA of hemisphere is 2772 plus CSA of frustum is 1092. Total the CSA is 5184 centimeter square. So if you like this video, please like, share and subscribe. This is the end of 2024 March-April maths question paper. Thank you.